Hello and welcome to a fun problem sheet about if and only if. So just like and, if and only if is one proof that's built from two proofs. But P if and only if Q means P implies Q and Q implies P. And so the cases and split tactics are still going to be useful for us here. So for example, for P if and only if P, I can probably split that. Yeah, if I split it, I've got to prove that P implies P and that P implies P. So I guess the way I would prove that P implies, so I've split it, so now I've got two goals. And so to prove that P implies P, I can just do intro HP, exact HP. So that would, there we go, that's proved that first one. And now I've got to prove exactly the same goal again, which is a bit of a shame really. And so I guess one trick we could do here would be use a semicolon instead of a comma. Because then that next tactic block there, after the semicolon, it means do all of these tactics to every single goal that appeared just then. So there's a proof of that. P if and only if Q implies Q if and only if P. So I could start with intro H. And now here's a mistake you can make. We can start taking everything apart, right? We can do cases H with HPQ, HQP. Well, it's not a mistake as such. And then we can split here. And now you can see, now we've got two goals. I guess we could do, and then this one here. This one is exact HQP, and this one is exact HPQ. So that's a perfectly good proof, and of course we could be because both of these we could prove by assumption. That's an assumption, and this is an assumption. And now we can see we can make it a bit smaller by using the semicolon trick there. And I guess we could also make this smaller by doing, instead of intro then cases, we could just do rintro HPQ. I mean, I could call them underscores. Then I think Lean will name them automatically. Yeah. So if you call, if I just put underscores here, then Lean gives automatically generated names to these things, which are intentionally hard to type. So there's a proof. But actually, there's a much better proof using one of these new tactics. In fact, I've just realised there's a proof. I could prove this using a new tactic here. Look. This one here, oh, that's a much better proof. I can prove that using refl, because if and only if is known to be a reflexive binary relation. And this one here, after intro H, I can use this other new tactic, the rewrite tactic. If I rewrite H, that solves the goal. That's slightly terrifying. The fact that that's happened so quickly. And the reason it's happening is that the rewrite command turns the P in the goal to a Q, and then rewrite tries refl afterwards. So you see, after the rewrite, the goal becomes Q if and only if Q, and then the refl tactic closes that. So rewrite closes this instantly. And now this one, P if and only if Q, if and only if Q, if and only if P. This one I think I'm going to have to split. And then we've done this proof already. You see, what we should really do is we should give this a name. Lemma hello there. And then we can probably just apply hello. Yeah. There you go. Applying previous lemmas, that would be one way of doing it. That's a bit cheeky. Let's go back to the examples. What can we do here then? We could do, I guess it's the same story, right? We could do intro, the proof is intro H, rewrite H. That should work. There you go. That looks a bit more palatable. Now what's happening here? No, if and only if is transitive. Oh, okay. So let's do intros HPQ. Well, HP if and only if Q, HQ if and only if R. Let's just call them H1 and H2. Intros H1 and H2. And now we could rewrite H1 You see now that this rewrite thing, the goal changes from P to, the P in the goal changes to a Q. And then if we do rewrite H2, that would actually close it. But of course we could also do exact H2 there. But because H2 is a hypothesis, we could also do assumption. But there is actually a tactic that does rewrite and then assumption immediately afterwards. That's the RWA tactic. So probably this would do it as well. There we go. So rewrite and assumption. So RWA is rewrite plus assumption. And now what's happening here? P and Q if and only if Q and P. So I think probably we have to split this. Now we've got two goals, so now we could do rintro pointies H1, H2, and then exact H2, H1 there, and I guess that will work for both proofs, so that should probably do it. There we go. I mean, talking of slick proofs, things like Torto will solve all of these goals, right? Has that worked? Yeah, Torto solves all these goals immediately, but somehow Torto is cheating, right? Torto, you won't learn any tactics at all if you just solve them all with Torto. There you go, great. Doesn't achieve anything. So what now? Oh my goodness me, this is proving that AND is associative. This one I think we might have to do longhand, so we could split this. And now what? For this half, we could do rintro. I mean, we could do intros and then cases, right? What have we got to do here? We've got to get our hands on a proof of P and a proof of Q and a proof of R. So let me do one way the slow way and the other way the quick way. So let's do intro H. And now H is a proof of P and Q and R. So if I do cases H with HPQ, HP and Q, HR. Okay, great. And then cases HP and Q with HP, HQ. So now we know that we've got proofs of all of P, Q and R. And so now how do we do P and Q? Where do the brackets go? It's kind of interesting. It's not obvious, right? But if you hover around here, you see the brackets go there. And is right associative. So if we do split, now we've got two goals. And the first goal is just exact HP. And then the second goal, let's get my brackets sorted out. There we go. The second goal is Q and R, so I can do split here. And now I've got two goals again. There, and then this one. You see, the computer scientists want us to indent our code nicely. And so what's happening is every time I get two goals instead of one, I introduce more squiggly brackets and indent two more lines in. So what have I got to prove here? I've got to prove that Q is true. So that's exact HQ. And this one is exact HR. So there we go. That's done one way. That's sort of done it the longhand way. And then this way I'll just use rintro. I'll just use the pointy bracket trick. So this one I can do rintro HP, HQ, HR. So that's got me. You see, that's the first. The intro and the cases I've just done in one line here. And then exact, because the brackets are there, it's going to be like this, right? HP, HQ, HR. There you go, that's worked. So there's the sort of the shorthand way of doing it. Right, what's going on here? P if and only if P and true. Okay, that sounds true. I think I'm going to have to split it. And then this one is intro HP. So let me do these things properly. There. Intro HP. Oh, nice. That's right. Yes. There. Intro HP. Now I'm going to prove P and true. Okay, so split, and then this is exact HP, and this one is I've got to prove true, so that's triv. And now this one, I could do rintro HP, and then I don't care. The difference between minus means don't even bother introducing that into the tactic state, and underscore means introduce it into the tactic state but give it a silly name. So I'll put minus because we don't even need it. Who needs a proof of true, right? And then exact HP. So that's done. That one, false if and only if P implies false. Again, I think I'm going to have to split. This one, I mean, I could do intro H and then X falso and then exact H. Or I could do intro H, then cases H. But when you do intro and cases, it should be rintro. So I could probably do this. Rintro. Can I do this? There we go. That's done it. There aren't any cases. So yeah, this one goal here is proved by rintro pointed. There you go. That's kind of a cool. There's a very cool proof of that. And now what have I got to do here? And so again, I can probably do rintro. I guess rintro. I don't care about. Can I? I'm not sure I can pull this one off. Can I? Oh, can I do this and then this here? So there you go. There's there's a proof of that. I mean, you know, there are other proofs, right? You can just do intro and cases and X falso, but let's just get on with it. So what am I doing here? Intros HP Q, and I mean H1 H2, and I can what's the proof of this? I can just use rewrites here. Rewrite H1, rewrite H2. There we go. We've done it. Because after the second rewrite, this R becomes an S after the second rewrite, and then the goal becomes Q and S if and only if Q and S. And that's solved by refl. And remember, rewrite tries refl afterwards. And now what's this nonsense? Not P if and only if not P. Okay, so not blah is the same as blah implies false. So I can do intro H, and then I can do cases H. I think maybe there are ways of doing this. I think the easiest way would just be by. But why don't I just do a case split? Why don't I do this by cases HP there? Is this the right? Yeah, intro H. Yeah. Okay. Here's a way of doing it. Have HMP. Let me just do it by. Yeah. Oh, I'm in two minds. I'm a live recording, and I'm in two minds about how to do it. Intro H, cases H, with H1, H2. And now, does that help? No, that doesn't really help. I just have to prove P twice now. Okay, so I think I'm just going to do. Let's do by cases H. We're going to do this. There are other ways to do it, but I'm going to assume the law of the excluded middle. Let's assume that P is either true or false, right? So, I've got two goals now. So if I've got two goals, I should do this, there, and now what's happening here? So this one I can apply H1 probably. And now I've got to prove P twice, and that's assumption. So that's done that one. And this one, I've got to prove false. I mean, can I apply HP? And now I've got to prove P, and now I can apply H2. And now I've got to prove not P, and that's an assumption, exact HP. So there you go, there's one way of doing it. This is quite a tricky question, is to prove this constructively, prove this without using by cases. While I'm here, why don't I just see if I can remember how to do it. So intro H, and then I think the trick is you prove that you prove not P, I think. So so this have tactic, the idea is I want to prove an intermediate. This is sort of proving a sublemma. I claim that not P is true. And how we're going to prove that, I'm going to do cases on H. And now I'm going to do, what I'm going to do? I should never have launched into this. I mean, I suppose I'm here, so I may as well try and finish it now. And now intro HP. And now I've got to prove false, but I can probably do that. I can apply, I should have given these names with H1, H2. And then apply H1, and then in both cases assumption works. So that what I'm trying to do here is I'm trying to show you I can do it without doing a case split. This proof here I say, well, either P is true or P is false. But in constructive maths you're not allowed to say that. So how are we going to do this one? Now I can just apply HMP, and now I can rewrite H. There we go, an exact HMP. So there's a proof of this last example in constructive mathematics, if any of you care. Right, thanks a lot for watching.